Good morning, everyone. Hopefully you're all doing well. I have had a good think about everything from last week, and I think everything's good. I think this version of Jugglebot still has a lot of life to a lot of life and love to give, and I'm keen to make some changes to this design so that we can fully see what this design is actually capable of before moving over to the cable robot. So if you've been pining for a cable robot for the last little while, you're going to have to hold your horses for just a little bit longer. I think there's still a bit of work to do with this design, as I'm sure most of you will probably agree from seeing what happened last week. But yes, I hope you're all doing well and are ready for this week's stream. So just before we start though, I want to answer a request from one of the viewers who has been quite helpful so far. Their name is Alice, and they were asking if I could introduce our beautiful cats. And I'll try to keep this brief, but I think it's useful because you got to know who's in the family, who's around in the background when I'm recording these. First up, we've got Albie, who's a little menace. He was the one who was in last week, causing havoc by whinging lots, and he likes to be upside down. And then we've got Marlo, who I don't think he's been in any of the streams so far. He tends to kind of stay back a little bit more than Albie does. But he loves poking his head through things. He's very curious. And then both of them together, and they love each other. They're twins, two cats from the same, two from the same litter of 5. And they are the best. They are together the best cats that have ever lived. They're so good. And yeah, you'll probably be seeing more of them in the future. They'll be in and out. They have an important role to play with Jugglebot. And also, related to Alice, I tried what you suggested. I ran this command, and I got this, which, I don't know. Oh, my camera goes on top of that. I tried to put this shrugging thing so that it would be on top of me to represent that it was me shrugging, but I forgot that my camera would go above that. So pretend that this is me. I have no idea what this means. Yep, I don't know. Anyway, for everyone else, onto Jugglebot stuff now. So the biggest change that I think is due for Jugglebot is to get rid of the magnets in the magnets that join the legs to the platform. I reviewed the footage back from last week when I was trying the throw and catch attempts, and by far the biggest issue was just the magnets would just lose grip, lose adherence for just a smidgen, just a fraction of a second, and as soon as they've lost it, they're gone. And very interestingly, I actually noticed that there was one time when the platform fell apart when it looked like the motor was actually just yanked the legs straight off the magnetic connection, which is pretty impressive because I don't think I've got one of the magnets here, and I cannot separate these by hand directly. I have to get pliers to lever them apart. Granted, this is it's kind of hard for me to hold this little screw thread, but even when they're actually on the legs, I have not been able to just pull them apart. And yeah, I'm pretty impressed that the motors can do that. I think that bodes well for the power of the motors for the design that I will show you in a sec to get rid of these magnets. So just to fully encapsulate my thinking right now on the magnets, the bigger issues with them is that they're just too weak. They can't, if the motor is strong enough to just yank the leg out, that's not going to work. And I don't want that. The joints shouldn't be able to withstand whatever the legs can put out. They're also super heavy. I have known that these have been heavy for a while, and oops, I'm not on the right screen. Yeah, I've known that these have been super heavy for quite a while because obviously you can tell straight away, but I didn't really realize the implications of this until last night when I weighed them and I compared them to the new design, which I'll show you soon. And yeah, these each are 195 grams. Versus my new universal joint, which I will show in more detail soon, but it's pretty much identical to the one that I had a couple months ago, is 55 grams. And so if we're adding 6 of these together for the whole platform, we have... did what just break? I think that it looks like everything's still live for me. Let me know if anything's weird. Yeah, if we add all 6 of these together, we have almost a kilo for just the joint, versus 330 grams for the universal joint. And actually, I just realized before starting the stream that that's actually not even entirely true, because there are other nuts and bolts that are used to connect this to the legs. So they're probably not very much, but I would say a kilo for these magnet joints is probably correct, which is nuts. Like, that's a full kilo that I'm moving around at like maximum speed for not much utility because they're just so weak. Yeah. So the thing that I'm changing to are these universal joints, which, yes, you may remember them because, yes, I was using these before. And there was a video from 11 months ago where I was happily changing over from these joints to the variant of the magnetic ball joint that actually happened to be even weaker than these ones. Yeah, and I was pretty keen on that. That at the time, that felt like a very meaningful change. However, my requirements have changed now. So the problems with these joints before were that I needed is a strong word, but I wanted something really modular, because at the time I was making lots of changes to the platform, and it's really tedious to remove all 6 of these, because these are like fully bolted in, like this is attached, and it's very hard to attach and detach 6 of these while all of the legs are kind of like wanting to do their own thing. That's, yeah, very tedious. The magnets, on the other hand, I mean, you saw last week how quickly I can just like snap all the magnets together. It's very easy. Yeah, so that was something that was good before, but is less useful now. And also, these joints that I had before was weak. One of the parts, at least, was weak, and it broke at least once. I actually can't remember how many times it broke, but once is enough. And you can see the failure mode there. It just shattered around where the nut was. So, how have we resolved these problems? Well, the first is that I no longer want something modular. I'm pretty set on this platform design for now, at least, and I don't anticipate that changing anytime soon, so I don't care about modularity anymore. As for the braking, I've just made it thicker, essentially. And also, notably, I've changed the thread interface to be, instead of hex nuts, which were what was sitting inside that little void there, I have threaded inserts. So I've got one here, freshly printed, and you can see there's no hole anymore where it broke, and instead a threaded insert will just go in that spot there, and that should be a lot stronger, hopefully. I've also made the whole outer thickness just a little bit bigger, and I think that this should be a lot stronger. Yeah, these... I'll address this last question here, the contraction string, in a sec, because I think it'll make a bit more sense in a sec. I didn't have as much time this week. I was too busy catting everything, and I kind of forgot about making the presentation, so things are a little bit weird. But yes, so that's the first change that I want to make, is to change the magnets from magnets to these universal joints. I think that will make things much stiffer, and I'll be able to actually pull and push much, much quicker. And also, in case you're interested, these have 0 play in them. This joint has full range of motion. I can go wherever I want. This last bit twists, and yeah, it should have an extremely wide range of motion. There is one problem that I can think of with these, which is that if they ever are in an orientation like this, they tend to not be very happy. It's the same sort, I believe it's the same sort of principle as gimbal lock with using Euler angles. But yeah, it can get a bit funny if it's right at the, if both of these, if everything's collinear basically, but hopefully that shouldn't happen. I've moved everything around in the CAD quite a bit, and it's very, very extreme situations where this happens. So I think I should just be able to avoid putting them in that position, essentially, which is a bit of a non-solution to that problem, I think, but it'll do for now. If that ever happens, then we'll see. We'll just deal with it then. Darkman, whether the inserts got yanked out, I don't think so, because there is not going to be much load on most of the inserts. There's one insert. So there's one insert in These all have the brim around them still. But this piece here, this like U bracket that goes around the outside, has a threaded insert in the bottom of it to connect like this round thing which goes onto the leg to the rest of it. And that one will be subjected to purely, in theory, purely axial loads. So maybe that one will get pulled out, but I don't think so. I think the motors are strong, but like the amount of effort to pull that out, I imagine will be much, much more than the amount of effort to just move the platform the corresponding amount. So I am fairly sure the platform will just move instead. I think the problem before was that the platform has so much inertia that if the motor made a really rapid change powerfully enough, that it could separate the magnet, because the inertia of the platform just didn't want to move, especially because like these is just so massive, added to the inertia of the platform. But now that things are lighter and more rigidly connected to each other, it should just pull it down. I mean, we'll see. But I would be very, very surprised if they pulled out. Especially after seeing the videos that CNC Kitchen made about like the strength of 3-in-3 inserts, threaded inserts. Yeah, so that's change number 1 from last week. So get rid of the magnets and put in universal joints. Just make everything stiffer, better linkage. The next change that I want to make is to increase the motor current. And this is something, I don't know how I forgot about this, but I don't feel super comfortable doing a lot of motor tuning stuff. Like there's all this PID tuning that you can do with the O drives, and I just got it to a point where it kind of seems okay because I don't really know what I'm doing there, and it feels like I'm just kind of wading through like a fog and I don't really know what I'm doing. And one of the things that I changed pretty early on was to set the motor current to be 20 amps. That was the limit of how much current can go to the motor. And I just set that because it seemed like an okay amount and it was fine for all my testing, and that's what I've been using like literally the entire time. All of these linear actuator tests that I've done, everything has been with 20 amp limit. But the motor drivers can handle a peak of 120 amps per motor. I think the happy continuous level is like 70 amps or something like that, but still like multiples more than what I'm currently using. And my understanding of how voltage and current works with motors is that if you add more current, you get more power, and more power means more force, and more force means more push. And what kind of tipped me off to the fact that this might be something worth looking into is that I noticed in the stream after the fact that from last week, that when the robot moves down, it moves down very, very quickly. But when it moves just straight up, it moves up much more slowly. And that kind of made me realize that, like, of course, gravity is helping it move down and it's dealing with the weight of all these magnets and everything. But when it should be able to push up much, much faster than it was before and what it currently is. And I believe that I could just simply increase the motor current, and maybe that will be enough to get the robot responding faster when it's pushing up. However, I don't want to do that right now because I want to wait for these universal joints, because every time the robot collapses, I mean, you saw last week how much of a hassle it is to bring everything back online again, and I don't want to be doing that all the time just because the magnets can't keep up. So I want to make the change to these universal joints, which just finished printing yesterday. And yeah, I think once I do that change, I'll bump the current up and then we'll see what we can do. It should be able to push a lot harder, I think. Running into stop travel limits. I might go into the comments at the very end, I think. I think it'll be a little bit less distracting for me. Yeah. So that was the second change. Should be pretty easy. Just change that number up. I'm thinking the only niggle in the back of my mind about this one is that this may lead into more problems with the brake resistors again. And thinking back, this might be the reason why I set this limit to be what it was, to be the 20 amps, because if I have it much higher, if I have it any higher, then they'll be putting more power into the motors, which means when the motors are slowing down and they're stopping the inertia of the robot, they need to dissipate that power somewhere. And that power has to go into the brake resistors, which I don't have any. Actually, I do now. Yeah, I've I think I broke one of them before. I don't know. It seems to be going a bit weird. But I've now added these heat sinks to them. And I think that this should be a lot better at... I mean, it's not really focusing very well. This should be a lot better at dissipating the heat. But I don't know. This is my only real concern with upping the current, is that I may need to be a bit more conscious of what's happening with my brake resistors. It's a bit concerning that I might have broken one as well, because I only have 4 and I need 4 now. No more spares. All right, yeah. The third change that I want to make, the third and final, is that this has been a bit of a contentious point within my own mind and also in discussions with people, but I think the hand motor ought to return. I had a hand motor like a year ago or so. I was very confused by all the inverse kinematics. I was umming and ahhing for a long time about whether or not to include one, and previously I decided that I wouldn't add one because it just makes the inverse kinematics so much more complicated. However, I have since had a very, very useful and insightful conversation with Burrage, who is a professional juggler, and he saw my live stream last week and he thought, all right, I need to have a chat with Harrison and let him know my thoughts as a professional juggler. And yeah, that was a very, very good conversation. And I actually want to show you now a short clip from our chat. I would like to publish this entire conversation as just a full conversation. It was really good, and I think that a lot of you would get a lot out of it. But unfortunately, I screwed up my audio recording on OBS, and my audio is like a 1.5 second, has like a 1.5 second of millisecond delay. And I've tried all sorts of different like echo removal software and everything, and I just cannot remove it. And it makes my audio very hard to listen to. But thankfully, Luke's audio is great. So I will be showing you a bunch of little clips throughout, in the future. But for now, we've got this one. So if I just change my audio around. Let me know. Why is this not playing anymore? I promise I tested this and it worked. Hang on. Yeah, I don't know why the audio...
Fantastic
oh, here we
for
go.
Angling.
All right, let me know if you can't hear anything. I need to mute myself to get this to work, but yeah, post if you can't hear it.
I wouldn't even want to start thinking about like what level of stepper motor control that you need to actually do the throwing motion as smoothly and as accurately as you want to do this. But these platforms are fantastic for angling and moving to catching. So I would say this little motion that you had here, which is like pull on a string and the ball pops up, think about having that on
as an isolated movement.
as an isolated thing, so you can get the hand into the right position, and then when the hand is in the right position, you pull on a string. However you make this work, so it's in a position, it doesn't move. You pull on a string, the ball does exactly the same motion perfectly each time, and you know it's going to be the same thing because you're literally pulling on a string like this. And every time you pull on the string, the ball goes woo, and then you can use the fantastic lateral control in this plane to get it to the place where it needs to do the catch, and it can come down in there and it can go to the bottom, and then you can move it over where you need to go, and then a single string and pop it up like that again. That's for the what you've built so far and what your plan is. I would really suggest that make the most common and most important to be accurate thing that you're doing, which is a throw, and you always want that to be consistent, you always want it to go to the same height, make that into a single operation with a single actuation of a single motor in a single direction in a single plane. Like, again, just make that bit, which is what you want to do repeatedly over and over and over, because you want to get that 13-hour record or the 7-ball record or something. Those throws make that operation not rely on 6 or 7 motors all working perfectly together. I wouldn't even want to start.
Yep, I for one found that very helpful. General idea is simplify, make the throw movement as simple as possible, and then deal with catching as complicated as I need to. So yeah, I think this formulation is very good, and it actually has very interesting implications for quite a few parts of Jugglebot, which I was a little bit surprised about as I was kind of thinking about what this meant more and more and more. To fully explain why this is so revolutionary for me, my thinking so far has always been to try to make everything as kind of like cooperative and holistic, I guess, as possible. Because in my mind, like the way that I've always formulated my own juggling is that everything is working together for both the throw and the catch. I've never really conceptualized it as the throw is primarily imparting vertical velocity to the ball, which is mostly just a single operation, as Luke describes. But I think having it framed this way makes a big difference, because it just makes everything a lot more simple. And yeah, so what does this mean for the kinematics of the robot? I have always been thinking if we add a 7th hand motor, then there's going to be all sorts of weird ambiguities between how much of the push do we want to come from the platform moving, because there's always, as long as the Jugglebot is like strung up the way that it currently is, there's always going to be some relationship between the platform moving and the hand moving relative to the platform. Unless the motor compensates for that and cancels it out, that string length change is always going to be there as the platform moves. So there was always this thought in my mind of like, how do we distribute the throwing push, let's say, between the platform moving and the hand motor moving? And I was always just like, I don't know, I can just kind of arbitrarily assign like 70% to the hand motor and 30% to the platform, or 80-20 or whatever I want. But I'd never really considered to go the full 100% of the push comes from the hand motor and 0% comes from the movement of the platform. I don't know why that didn't really come to my mind, but it never did. And this has very interesting implications for a few things, one of which is the kinematics, which could become much simpler, because we can break the path into 3 components. If we keep the same like Bezier-ish shape of path, we can break it into 3 components, where we have the platform XY position. So the platform, at least the centroid of the platform, will only ever move in the XY plane at some height that we've just decided arbitrarily. But if that moves purely XY, granted we can adjust the Z height to compensate for timing, which was something that Alice and Charlie mentioned, I think 2 live streams ago, which is that when they are juggling, they try to emphasize timing of catches rather than the position of the catches. And I do this as well. And so you'll find sometimes you catch up here, sometimes you catch like down by your waist. And giving Jugglebot that ability would be pretty good, but that's a problem for later. For now, I think we can just keep the platform moving in just the XY plane. The second component of the movement would be the platform, and hence the hand, because the hand is linked to the platform, orientation. So that can move between like the incoming orientation and the outgoing orientation. And then the third component would be the hand position relative to the platform. And by combining all of these and kind of maybe handling them all individually, we can construct so that the ball and the hand would follow approximately the same path that it would have been following before with my Bezier path planning and everything. But rather than having to figure out this Bezier and all of like the time increments and everything to get everything to be spread out nice and smooth, we can just do 3 things and maybe just handle them all like just a linear interpolation of all 3 of them. Maybe. We'll talk about that more in just a sec. Actually, no. Yeah. So, yeah. Yeah, maybe we can do these. I need to think a bit more about how to distribute the 3 of them. Like I've been thinking that maybe we can have the position. I can still create the Bezier. Creating the Bezier is very fast. That bit's easy to do. But my thinking is maybe we can create the Bezier and then do the position, so that if we like project this down onto the XY plane, we can just basically take all of these points and just map them down, and then have the robot just follow those points and just move between them. And it's kind of like a linear interpolation, but a linear interpolation informed by a path. I think for the orientation, it feels easiest to just linearly interpolate. I don't know how smooth that will end up being, but we'll have to see. And I'm not too sure how to do the hand position. Luke's suggestion is honestly probably what I'll be doing at the very start, which is to just like move the platform into position, throw, move it into the next position, catch, move wherever I want to move, throw, move, catch. So it's a very like, I don't know, static sort of trajectory. But I would like at some point, it has to be that the movement and the throwing action are combined into one, because there just isn't enough time when you're doing like 5 balls or even 7 balls between 2 hands. There's just not enough time to catch, move, throw. You have to be doing them together. But yeah, I think at least at the very beginning, it probably does make more sense to just go move, throw, move, catch, or even just like throw, catch, like that sort of thing. I don't know. I think, yeah, keeping it simple at the beginning is a good idea. Another thing that is impacted very interestingly by this sort of change, by restricting the platform to move in the XY plane, is that 2 things have now become one thing. They're actually now just the same thing. And to have perhaps a less cryptic title, what does this mean what does a hand motor mean for Jugglebot geometrically as opposed to kinematically? So if the platform is only moving in the XY plane, then that means that the global hand position in the Z direction is limited to the hand stroke. The maximum position that it can be is the XY plane plus half of the hand stroke, let's say, and the minimum position that it can be is the Z position of the platform minus half of the hand stroke. And that's it. Before, in the way that it's currently set up, it might not seem super obvious, but if you think it through, you should be able to come to this conclusion that the maximum position that the hand can be in is effectively double the hand stroke, and the minimum is, I guess, 0. So like the range is from 0 to 2 hand stroke, versus now, if the platform can only move in the XY plane, then that entire span of like Z values that the hand can take is exactly limited to the hand stroke. Which means that 2 previously arbitrary values are now the same thing. The first is the position of the control points. Let me draw. For this bezier, this like hold bezier, and the same thing for the throw bezier. I've just been setting this distance here to be an arbitrary value. I just pick it and I say, yep, 0.3, done. And that's actually one of the things that we can change in the GUI, if you remember from last week. But yeah, that's just been arbitrary. And the other arbitrary thing is the length of the cage part for the hand. So it actually might make more sense if I show you this in CAD. So if I bring this down here. So the length of, let me open this up. The length of this part here. It was like kind of intuition, kind of just like, I don't know, playing around in the CAD and hoping that things, and like seeing what doesn't make collisions happen easily was basically it. But this length of like where the hand can travel through was fairly arbitrary. And now both of these 2 things are the same thing, because as the hand moves through, if the platform is only moving along here to here, the hand is at the top of its stroke and it can move down to the bottom of the stroke, which is the bottom of that hand cage thing, whatever you want to call it, and it can only move within that range. The more or less part here is that as the thing as the platform changes orientation, that Z distance will change slightly, but only very little. And so those 2 things are effectively now the same thing, which feels good to me. This may be just because I'm too, I don't know, in the mindset of like when I was doing like engineering at university. But I remember it's always a very nice, satisfying feeling when you have some really complicated equation or like set of equations and you realize that 2 of your unknown variables are actually the same thing, or you can just get rid of one of them, or whenever one disappears, it's nice because now you have less uncertainty and more things I don't know, it's easier to kind of understand how different variables affect one another when you have fewer variables to deal with. And I think this is good. This feels nice, feels natural, you know? Maybe not, I don't know. So what does all this look like? So let's go into CAD now, even though we were just in CAD before. So this is all the same as before. You can see I've now got the new joints in place in the platform. Oh, what do you want? Yeah, so we've got our new joints in the sides, and you can see even as I move this around, we don't really need this to be so big. As I move this around, I don't know if this is going to be too happy doing this, to be honest, while I'm streaming. But all of these joints, I have not been able to put this in a position where the joints seem super unhappy. So I think this should be fine. I could also play around with, and I was considering doing this, playing around with like the orientation and the position where these joints meet up with these like, I don't know, bigger bracket bits. I don't know what you call them. Main nodes, I've called them. And yeah, I could play around with that, and that would maybe help if I find that like in certain positions the joint just breaks or something. It might be worthwhile changing that orientation to alleviate forces when it's in that position. But I think this is a good, simple. To be honest, I mostly just did this because this was the simplest option, because these things, they don't have a whole lot of space inside them. There's a lot of other things going on in there, and these were just like the thickest bits because these other like sticky outy bits are there. And so that just gave a good mounting spot, and it keeps most things the same. One thing actually that I will mention now that I will probably forget, and I don't know, I ought not to, but we'll see, is that because these joints are slightly different to the magnet ones, I will have to go back into ROS and change all of the geometry of the robot, because it may not be super obvious immediately, but it is the case that if the geometry changes at all for the whole Stewart platform, the inverse kinematics are affected quite a bit, like proportionally to that change. And this change is non-significant. Like the whole platform drops down a little bit, the connection point moves out a little bit, and I will need to make sure that I go in and update those because I haven't yet, and I could see myself forgetting, to be honest. Okay, so that's that. But now we've got a hand motor, and just to describe this problem fully, let's open the platform back up. And we can see, I haven't actually included these in SolidWorks because they're a little bit annoying to deal with because everything moves around so much. But there are 3 strings, and you can see like one goes into this hole, one goes into this hole, and one goes into this hole over here. These 3 strings are completely independent from one another, but I need them all to be the same length because they tie in here and they tie off down the bottom. I just put like a knot in the bottom so they can't get pulled through. And then that goes up over these pulleys, straight down into this hole in here, in which there is a PTFE tube, so it's not quite as large of a hole as it looks in CAD, because again, I haven't included the PTFE tube because it doesn't really need to be there. That then comes out the bottom and out of here. And that's where it leaves the platform. Oops. And then those 3 go down, and previously, there's a bit of a spoiler, I'm going to cover that up. Previously, oh my god, it looked like this, if it will load. Come on. All right, it doesn't want to change. But previously I just had this, this thing here, where the strings would go in, and then using these little sliders in here, I could adjust how long that string is relative to the other ones. Because at the end of the day, the attachment point on the hand is just a knot. The attachment point at the end of this little adjusty thing in here is also just a knot. And I have learned the hard way from experience that I cannot tie knots in a millimeter precise position. I would be impressed if anyone could. So I have realized that I need some way to adjust the length of each of these 3 strings because they need to be exactly the same. If they are not exactly the same, then the hand will pull up at a weird angle and it will not be straight. And that will be very annoying to compensate for in like control and software and everything. So yeah, my solution before was that I had these 3 little length adjusters. Obviously they don't move together, they just move that way because I'm lazy and I just circular patterned them in the CAD. But yeah, there was just like a bolt that came through here, goes into a threaded insert, and that slides this back and forth. And that works really well. That gives me, I think it was about 20 millimeters of play on either side. And that's enough to get them all to be exactly the same. One thing I will mention here is that something that I really liked about this design and what really helped me to get these 3 strings to be the exact same length is that I could raise the hand up so that it was pretty much at the very, very top of its travel, and then adjust these one at a time until the hand reached its like the top of its travel. And by having the tensioning mechanism down the base made it a lot easier to adjust the height of the platform than previously. A while ago I had the tensioning mechanism in the hand itself, and that's a little bit harder because then when I'm screwing to adjust, I'm applying forces to the hand, and I can't as easily see what effect that tensioning is actually having on the hand position itself because I'm pushing onto the hand. So ideally, tensioning mechanism is on the base and the hand is just kind of doing its own thing. With that said, this is my plan for the hand motor now. So you can it's pretty kind of space agey design, I think. Most of the reason why I'm doing this is because I have a bunch of these like short lengths of carbon fiber tube left because I bought an extra set of all of the tubes and everything that I needed for all of my actuators. So I actually, for a little while, I actually had 7 of these actuators just in case one of them broke. I could just really quickly swap in another one, and that was really cool. But I have since used some of the other extra carbon fiber tubes for the platform because I didn't want to have to buy more. And so now I don't even have enough spares anyway. So I figure I may as well just use all the rest of my spares because I don't have enough anyway. So I may as well just use them all. So I wanted to make use of these tubes, and I wanted a design that looks really kind of sexy, which I think this does a little bit, at least to me. But the thing is, I have not yet figured out a way to route the strings so that they go around this spool. And I spent quite a while over the last couple days trying to figure out some way to put the tensioning mechanism or like the length adjusting mechanism in here, in like somewhere here. But I could not figure out a way to do it that would look nice and would work. Well, looking nice isn't really a problem, but something that would work and actually be manufacturable. And yeah, so what I've kind of committed to now, I haven't had enough time to CAD this because I just thought about this yesterday, but what I've kind of committed to now is just having this routed the same way that you can see here. I will probably offset the 3 strings so that they kind of wrap around this spool at different heights so that they don't interfere with each other. This is one thing that I've been thinking about a lot, is that if I have 3 strings wrapping around the same spool at the same position, will that work? Will they tangle with each other? I don't know. But in any event, it feels safer if they are stepped a little bit. I did consider making this spool 3 spools so that they do have their own kind of individual channels to run into, but I don't think that's necessary. Keep in mind as well, with this size of this spool, the strings will only wrap around like 2.5 times, so there's not a whole lot of wrap, and the strings are thinner proportionally to the spool than they look in the CAD here. I've just made them this size because that way I can actually kind of see them a bit more easily. So if I'm not going to put the tensioning mechanism here, there's only really 2 other places it can be. It can be in, oh, I'm in the wrong one. It can be in the span between this point here and the hand, at the bottom of the hand, or the bottom of the platform, which feels dangerous because there's only actually a very small amount of string there that doesn't go fully into the motor or fully into the platform up above. There's only like 5 centimeters or so. And if I just change the geometry of the robot around a little bit, then there won't be any string that will not move into some tube somewhere. And so it can't can't really be in that middle span. Leaving the only other option that I can think of that's like kind of elegant and nice being in the hand itself, which I'm not super happy with because of the problems I mentioned before. While I'm tensioning these strings up and getting them all to be the same, it's going to be a little bit tricky, I think, to get them all to be perfectly identical because of the fact that I'm pushing against the hand while I'm making these changes. But I don't know. I guess I'll just have to, I don't know, figure it out. The saving grace for all of this is that I only need to do this once. And once I do this once, and as long as nothing breaks, it will stay the same for a while. So that's really the only reason why I'm okay with putting the tensioning mechanism on the hand. If this was like the legs and I had to do this 6 times, then I would be a bit more incentivized, I think, to like spend a bit more time to try to get the design to work down the bottom here. But I can't figure that out, so I don't know. Yeah, there is one other thing that I would like to add in here, which is that the calculations that I've done right now as for how much oomph this hand motor can give to the ball just purely by itself, with this diameter spool, it should be able to throw the ball. I think it was... I had to restart my computer, so I don't have it open anymore. But I believe it was like 1.4 meters, something like that, which is pretty high. Like that's higher than I need to juggle 5 balls. So that should be pretty good. But the problem is that is accelerating as fast as it possibly can. Not actually, it's accelerating very, very fast until the mid stroke of the hand, and then it's immediately decelerating. And if it spends a little bit too much time accelerating, or it doesn't decelerate fast enough, then the hand will just reach the top of its position and something will have to give. I have no idea what that will be. This whole system here feels pretty strong. This, like obviously there's nothing actually holding this together right now, but I intend to make this part reasonably strong with a big asterisk, which I'll get to in a sec. But the rest of it, this part is all super strong. Like if we go into the platform model, you can see when the hand moves up, at the very top, it actually makes contact with, like the top face of this part makes contact with the bottom under here. It doesn't actually touch the pulley. The pulley's slightly, it's kind of hard to see, but the pulley's a little bit in, but it makes contact with these 2 flat faces here. And yeah, I don't know what will break in this case. The pulley is held in pretty well. This part is solid, like where all the tubes are routed through. I have no idea what would break. So what I would like to add is some kind of mechanical fuse. I don't know what this is called normally. Like there's shear pins is a similar sort of idea. But I basically just want something where as soon as the impulse is high enough, this thing, whatever it is, will break and it will stop other things from breaking. And I'm not 100% sure how I'm going to do this yet, or if I will do this. I've had a bit of a think about different mechanisms, but it's a little bit tricky. I can't think of a good spot to put this sort of fuse. I think maybe a good spot would be in the length of the strings themselves, but then it's the same problem of like they're going to get sucked into the motor, or they'll need to go up into these tubes in here. So I don't know. A mechanical fuse would be nice, and to be honest, I have a sense that if I don't put one in, I'm going to regret it because something will break that I will not easily be able to replace. But I can't think of where to put one, so I don't know. If you have any ideas, I would love to hear them. I will read through the comments in just a second. But yeah, that's all I wanted to show in the CAD. Yeah. Cool. So, back to PPT. So what's next, you ask? Well, first thing is to finish the hand motor design. So everything that I just talked about, get it done. Get something to actually support those pulleys and not have them just floating in space. That's the biggest bit. Maybe add a mechanical fuse, hopefully. We'll see. Another thing is that in the CAD, or in the robot right now, we have 6 motors and 3 O drives, because each O drive can command 2 motors. There's one connects in here and one connects in here. So we have three O drives to power 6 motors. I am now adding a 7th motor, which means I need to add a 4th O drive. And this really fucks with the symmetry of Jugglebot, which is really pissing me off. I didn't anticipate having to do this when I made this design, and I love how symmetrical all of this is. It's so satisfying. But I need to add a 4th O drive somewhere. I'm thinking I'll just copy the same box design because it works and it's simple. But it's going to have to like go over here somewhere, and that's really going to add 2 spare. That's a funny idea, actually. Well, for better or worse, and definitely for worse, I think, in this regard, I actually don't have any more spares now. So not because anything's broken, but just because I'll be using them all. My plan was to have, 6 motors, 3 O drives, and I was like, okay, cool, I'm going to be proactive, and in case something breaks, I'm going to get a 7th motor, a 7th encoder, and a 4th O drive. And that way, if any of these things break, I'll have a spare, and I'll be able to go back down to 6, and everything will be happy. But now, I'll have no spares, and these are all of them that I own. I don't have any more motors, I don't have any more encoders, and I don't have any more O drives. So if any of these break, Jugglebot is pretty screwed, to be honest. So let's just hope that doesn't happen. And I mean, I haven't broken any of them yet. So, and I feel like the stage I'm at now, it's pretty unlikely for one of these components to break. Putting it underneath, I don't know. This is flat on the ground, and there's this whole, like, Jugglebot has a good bit of mass behind it, and I think, I don't know, having something underneath might be a bit more annoying than I think it's worth. Because having this flat is nice. I can like slide it around on my carpet, but if I had anything sticking out, it would catch and like screw up the carpet. Fake O drives, yeah, I don't know, we'll see. I think I will just have to commit to ruining the symmetry, but we'll see. And I don't even know if one of these boxes will fit. I mean, let's see. I don't know how nice it will look. Oh, go away. So this is on here. Come on. Going that way. Yeah, I mean, actually, maybe this can be a good opportunity. So this is the Jetson that's powering the robot, and I just kind of have this dangling around. It's not actually attached. Maybe I can attach it over there. That doesn't look too bad. I don't know. We'll see. I'll have a play around with it. Yeah, let's get rid of you. Yeah. So, yes, I need to make some sort of things for that. And I need to install all the bits. So I've got all of the parts now printed for all of the new joints. So I am ready to install these, but I'm thinking part of me wants to wait until I've finished with the hand motor design, and once I've printed all those bits off, to just do it all at once, because when I make changes to, when this will load, when I make these changes, I have to replace these like nodes on the platform, which means de-stringing the whole thing. So these strings in here, well, this one string, because this is all just one, I'll need to take all of those out and, yeah, basically remake the entire platform, as well as restringing the legs, which I actually want to talk about in just a sec. Yeah, and it feels like it will just be simple. Like I'll only have to do that job once if I do everything together at the same time, because then I can restring the hand as well at the very same time. So I'm kind of wanting to wait until this like the hand motor design is done, and then I'll just do them all in one go. But I'm expecting that to take a while, because part of the annoying things, or one of the annoying things about this new joint design, if I can find where the legs are, there they are. Yep, sure. Previously, when we had the magnet joints, I don't have one, actually let's see if I can still open this up. Yeah, cool. Okay, so here's the magnet one, and if we take a cut through here, we can see there was a hole in the middle, and this was cool because it means that I could put the string, so the string that pulls the leg down, that makes it go shorter, that string went all the way up through here, through this little hole in the plastic part, out here, and then I would terminate it with a bolt in here. And that was pretty easy, like relatively straightforward. The string didn't need to go the whole way through. Like all of the string that goes from the bottom part here up to here doesn't move. That's all just staying inside the tube the whole time, and it's never changing. But now that I've got this joint here, let me do a cut in here. There is a bolt running straight through the middle there, and of course that means I can't put the string through. I could drill a hole in the side of the carbon fiber tube and then somehow, and like maybe string it up around the outside and like terminate it on the outside of here. Maybe that would work. But a different option, probably a simpler one in my opinion, is that I have just changed things around. So now that string terminates in this bottom piece in here. So if we get rid of this, that string will go up through this very small hole, out through one of these, which I will have to drill through the carbon fiber tube. Drill through the bolt. I do not have the tools for that. String will come out through here and terminate in here. And this is all well and good, except there's always an except. And in this case, the except is that before, when the string went all the way through and terminated on the end here, these cap parts on the end of this central carbon fiber tube didn't really need to be firmly attached onto that tube, because the string that was pulling the tube down was pulling on this cap, which pulled the cap into the tube even harder. And the string that was pulling the tube up was routed and connected onto the bottom piece, which meant that it was being pulled into the tube and kind of being like clamped on. So the strings were like holding the caps onto the tube, which was really nice because it meant that I just basically it was like an interference fit, just slide them on and they stay on. But now this top one is not doing anything as far as the strings are concerned, and this bottom one is doing both. So this means that when the leg is being pulled down, this cap is being pulled off of the carbon fiber tube, and there's a chance that if I was doing the same interference fit that I had before, that would just get yanked off. And that's obviously not ideal. So now I have taken the approach that I have done on all of the platform parts where the carbon fiber tubes go in, which is to drill a small hole into the carbon fiber tube, which is guided by the hole in the printed part, and then just put a bolt straight through the lot. And that so far has been absolutely solid on the platform, and so I figure doing the same thing on the legs should be fine. So this bolt that comes through and terminates the string, so the string will come through and then just wrap around the bolt a couple times. That bolt will also contribute to like holding this printed part onto the tube. And there's also one on the other side. Or if I'm feeling like it, I might just have one super long one go the whole way through. Let's see, I actually don't know if I have a bolt long enough for that. Yeah, it's slightly too long. I've got 20 millimeters and 40 millimeters, and this is 22.7 or 20.3. So I think I'll use 2. But in any event, I need these bolts here, and I'm also putting them on the top because it's not, I mean, if the magnets were being pulled off of the platform before, this joint would definitely get pulled out if I didn't have something firmly attaching it. So there's going to be the same sort of deal, bolts through here to fix this printed part onto the leg. And hopefully everything will be in like super stiff, super held together. But we'll see. And yes, as I mentioned, after installing all of these things, I will have no more spares. So fingers crossed that nothing breaks. After all of these bits are installed, I'll need to figure out the new kinematics. As I said, I think I will just keep it super simple and just have it move, throw, move, catch, move, throw, move, catch. And I have pretty good expectations for this, pretty high expectations. If this can, in fact, throw the ball to over a meter high, then I have no question in my mind that this version of Jugglebot will be able to do 2 balls in one hand, which is officially juggling. for those curious. Juggling is when you have more objects than hands throwing the objects. So one ball, one hand is tossing. It's not quite the same. So Jugglebot will maybe actually be able to be a juggling robot because it will be able to do more balls than the single hand that it currently has. And once I figured out the new kinematics, give everything more juice, pump that current right up, and then, I don't know, probably some other things that will come up as they come up, and then juggle. And yeah, hopefully that's soon. As I said, all of the prints, all of the parts are ready to go for the universal joints. And yeah, I just need to do the hand motor design, and that's about it. There's going to be probably like a day's worth of labor to actually install all of these parts. But I reckon like 2 weeks. I think 2 weeks is a good amount of time. I think next week will largely be finishing the design, trying to get some sort of mechanical fuse in, getting everything ready, hopefully printing everything. The week following that will probably be installing everything and doing the kinematics, and then hopefully just giving it a go. Yeah. Fingers crossed. 2 weeks. Let's see. Let's see, before the end of March, hopefully. Yeah. I think there were a couple other little things that I wanted to mention, but I can't remember them off the top of my head right now. Yeah, actually, if you're thinking about this sort of thing and you're trying to figure out a good way to do any of the things that I mentioned, one thing that I will say that I haven't mentioned yet is that it would be good if this hand motor design were strong enough to survive a ball landing on top of it. I don't know how I'm going to do that with the strings routed the way that they're shown here. But yeah, maybe I'll just have like a little deflection shield over it or something. But I think it's very naive to expect that balls will not hit this, because I mean already balls have tormented these electronics boxes and they've done a very good job of surviving so far. So I think I'll need to do the same for the hand motor. Actually, yeah, comments first. Jonathan, using a single string, then have rails for the hand. I'm not going to be able to find the design where I did that right now because my project management is not the best. But I did have a design at one point where the hand was guided by linear rails, and I still had 3 strings, I'm pretty sure. But a big problem that I had with that was actually aligning everything, because the prints have a little bit of tolerance in them, and these linear rails, at least the ones that I had with the linear bearings that I had, require very, very fine tolerances. It was just getting jammed in certain positions. Those rods, I couldn't keep those rods perfectly parallel for their entire length, and it was just getting jammed up. And I still had 3 strings. I don't know how you could do that with just 1 string, because it would always add a bit of a bending moment to it. I may be misunderstanding what you're saying though. Yes, you are right though, that the throw, during the throw testing, the hand wobbled quite a lot. And this is actually something that I'm not sure how I feel about it. Part of me is obviously concerned about it because the hand should not be moving in the middle of its position. Like if we go back to here, when the hand is at the very top, it's very well constrained, as you can probably imagine. And similarly, when it's at the very bottom, it's quite well constrained because there are 3 constant force springs around these 3 drums here, and they do a pretty good job of holding this down to the base. But in the middle, which is what we saw last week, obviously in SolidWorks, everything is nicely constrained, so it's going to only move straight up and down. But in reality, this is only held in place by constant force springs, which provide like 0 lateral support at all, and strings, which also provide 0 lateral support. So this can actually move side to side by quite a lot. And yeah, part of me doesn't like this because I'm not controlling that side to side movement, and it's just kind of doing whatever it wants to do. So it feels like it's not a good thing in that regard. But also, part of me feels like maybe it would be helpful because it will allow the hand to adjust a little bit better to the actual momentum of the ball itself. So if the ball's not quite ready to move in the way that the platform wants it to move, then the hand can kind of slide to the side a little bit to compensate for that. Maybe. I don't know. I'm talking out of my ass a bit here, but maybe. We'll see. In any event, I'm not hugely worried about it right now, but yeah, we'll see. I may need to add some sort of guide rails, and that actually could end up being a problem because, as I just said, I can't get the tolerances precise enough. So we'll have to, I don't know, cross that bridge in a little bit, I think. Unless I use an actual linear rail, in which case maybe it'll be fine, because those are really good. Those are very nice, easy to use. 3 spools for the 3 strings. Ooh, I'm not too sure what you mean by that, Zariah. 3 spools for 3 strings, then you can design each spool as an inner piece and an outer piece, which are moved relative to one another by worm gear. I would love if you could draw that out in some way. That sounds interesting. And I've considered having a spool for each string, but I need all 3 to be driven by a single motor. I don't want any backlash, and I want to keep everything as simple as possible. Those are kind of my big 3 design requirements, I suppose, for this design. I would love if you could expound on that a little bit, though. That sounds interesting. Yeah, you can join Zulip. Go on the Zulip. In the description to this video, there's a link to Zulip, which is, like, for all intents and purposes, basically like Discord, but it's not. And you can, if you don't make an account, you can view everything. You can just have a read through, have a little sticky beak at what's going on. But if you do make an account, which is free, then you can post and you can share whatever you want. So people have been sharing like GIFs and CAD and I don't know, all sorts of things. So that would be a good way. Or if you go to my YouTube channel, there's like a contact me thing and you can get my email and then you can just email it to me. That would also work. Yeah. Obviously, no rush whatsoever. I would appreciate if you could do that. Because I'm curious in your design. Yeah, so that's about it. There are a couple of things that I want to mention, but I'll talk about that next week. I think I want to prepare slides for it because I want to solidify my thoughts a bit more before I say them in the stream. But yeah, I think things are going pretty well. I was a little bit despondent after last week's performance or lack thereof. But after reviewing the footage and seeing what was actually causing Jugglebot to fail, I feel a lot better about it now. Also, by the way, if you're curious and you want to see, if you go back to the last live stream, I went through and put timestamps of everywhere where Jugglebot collapsed, and it's pretty fun to just like click on them and just watch it go. That's a bit of, I don't know how I feel about it. But yeah, I feel really good about these changes. I think that all of these things will contribute in their own way to making Jugglebot much more robust and effective. And I think all of them together, I feel very good about the next throw and catch attempt. I think it should be a lot more productive. Hopefully, we'll see. But again, like if anything does break, it means that the thing that breaks will probably be something I won't be able to replace. So I really don't want that to happen. I don't know. Getting rid of these magnets is a bit of a blessing and a curse. I don't know. We'll see how it goes. As always, I hope you have a good time, a good weekend until the next time I see you, and good luck with everything that you are doing. And yeah, until then, have a good one.